All right, sometimes we're dealing with inequalities. All right, and this is a system of inequalities, and here's a word problem that goes with it. I want to encourage you to look over the last problem. I'm just going to show you how to do one live here. And there's a couple, so we'll do two live. And this one says John has to buy two different kinds of rope. Rope A costs 60 cents per foot, and rope B costs 90 cents per foot. He needs at least 15 feet of rope. He wants to spend more dollars, no more than $18. So we have one equation based on feet, right? And then we have one equation based on money. So, I don't know, X is going to be rope A, and Y is going to be rope B. And I know if I take in feet, X plus Y has to be at least 15, right? So there's one equation. And then we've got one with money, and the first rope 60 cents, so 0.6X plus 0.9Y, we'll put our X in there, has to be, well, we don't want to spend more than 18. We can spend 18, so I'm going to put an equal sign in there, but we don't want to go over 18. You know what? These aren't too bad to solve with X and Y intercept, right? Because if I cover that up, my Y intercept on this guy is 15. And my X intercept on this guy, if I cover up my Y, plug in 0 for Y, that's what we've been doing, right? Is also 15. Right? Let's do it down here too. My y-intercept right here is really, to solve for that, I divide by 0.9, so that would be 18 divided by 0.9, which is 18 divided by 9, but you add a 0, so that's going to be 20. You can do that on your calculator if it doesn't make sense. And x-intercept, if I cover up my y, is going to be, you kind of see it there, just like that. It's going to be 18 divided by 0.6. So 18 divided by 0.6, which is going to be 30. Again, something I don't mind using the calculator for until your brain gets used to seeing that kind of stuff. So let's graph this. 15 is going to be in the middle here. They go by 2 and give us a 15. And 15 is going to be in the middle of this one right here. So I'm going to do my best to get from this 15 to the other 15. Let's see if I can do it here. There's one right there. All right. I really shouldn't keep going because we don't go into negatives on here, so it's just 15 to 15, right? And this one says to shade up. See that gradient? So I'm going to very lightly shade everything up here. And again, I don't have colored pencils with me right now, but colored pencils are a really good idea when you're doing inequality because then you can see where the colors overlap. So, all right. Now let's go ahead and plot this one. The y-intercept is 20, so we'll go up here to 20 and put a dot. The x-intercept is 30. Well, those are easier to see anyway, so I'm going to keep my pencil there and put my, here I go, boom, 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 boom. And thankfully they're both solid because I've drawn solid without thinking too much about it. And this one says less than, so I'm going to go ahead and shade down here. And all of this is down, so I'm going to go ahead and shade this region. Alright, right in here. Then I'm going to do a kind of a double shaded region so we can see that this stuff in here is darker. Right? Everything in the middle between these two is a possible solution where you're above one line or less than the other. Or if I was representing this, you have at least as much feet, but you haven't gone over the price that you're supposed to. Right? So possible solutions are, well, I could give you an ordered pair. I will. Let's say 216 or any ordered pair in darker or doubly shaded region, darker region. Right? So anything in this could be a solution. I really think we got two more and we're done, so let's try this again. Alright. Hopefully it's getting easy. So we're going to write a system for and determine if the point, now we've been asked, look, they say, is the 0.84 a solution? Well, we're going to find that out. So let me just adjust this a little bit. A student has to buy graph paper and printer paper. All right. So let's go ahead and call the graph paper X and the printer paper Y. The graph paper costs $3 a pack. All right, so we'll say 3X. The printer paper costs $2 a pack, so 2Y. Right? And there's got to be money, so it wants to spend at most 27. So we're going to say less than or equal to 27. And then we'll say X plus Y, because I see this. She wants to buy at least 6 packs of paper. So is greater than or equal to 6. All right, so not too bad, right? I can do this with intercepts. X-intercept. If I cover my Y, you can see that's 6. My Y-intercept, if I cover my X, you can see that's also 6. And over here, it's kind of easy too, right? My X-intercept, if I cover my Y, is going to be 9. This one's a little tiny bit tougher. My Y-intercept, if I cover my X, I'll just write it, it's going to be 27 divided by 2, which is 13.5. So we have a little bit of a decimal going on there, but we'll get it. And here we go. Let's get our 6 and 6 first. It's right here and right here. And I'm going to connect those two. There. All right. And this one says greater than 6, so we're going to shade up right here, shading above this. And then the next one, X-intercept, is 9, which is in the middle there. And the Y-intercept is 13.5. Wow, that's higher than this graph is. Did I do that backwards? You know what? I didn't do that backwards, but I should have probably read this down here, and I'm going to read this down here. This says printer and graphing paper. So I've kind of reversed them. In this situation, I'm just going to go up a few more. I'm going to go up. There's 10, 11, 12, 13, 14. We're going to go up to there. And probably not the best way. I should have probably read my graph. I just went in order. And I'm going to connect those. And from this one, I'm shading down. I'm shading in here. And a little bit shaded in here. So I'm going to have to change this to graph, because I chose the wrong axis. And this one I'm going to have to change to printer. But there it is. We got one more to go, and then we'll be done. I'm going to pay close attention to this. Uh-oh, look. This is even better. Now they've given us another option. So I'm going to say this time, X equals printer, like they have it, and Y equals graphing. So I've aligned my X with printer paper and my Y with graphing. Although I don't remember the cost, we'll go take a peek. I can do the at least 7 pack, so I could say X plus Y is greater than, plus Y. My brain was one step ahead. Is greater than or equal to 7. And let's get those costs again. It was 3 and 2. So which was which? Printer is the 2. And now, so it's going to be 2X plus 3Y is spend at most less than or equal to 30. Alright, so now we have our equations. And let's do this. Let's say my X-intercept. I cover my Y. Here you can see X would be 7. Let's say our Y-intercept. I cover my X. It's going to be 7. Now we can have more paper, and we can spend a little more too, right? My X-intercept, if I cover my Y, is going to be, I'll just do it right there. You can see it's 15. And my Y-intercept, if I cover my X, is going to be 10. And this one shades down, this one shades up. Let's get our 7, 7 on there. 7's in the middle here. And 7's right there. All right, so we're going to connect. I'll point something out to you guys on this after I shade this up. This one's shaded up. If I was going to use slope on this one, I was going to put it Y equals, it would be a little bit more difficult. You have to be super careful because the scales aren't the same. So if I had solved this and there was a slope of 1, this would be a slope of 1. I would go up 1, but if I went over a 1 based on this graph, right, that would be going up 1, this would be going over 2. So if we were ever going to plot with slope-intercept rather than x and y-intercepts, we'd have to be super careful when they give us a slope like this. Anyway, let's graph this guy. My x-intercept, now it's going to fit because I got it right, it's 15. I'm going to put a dot right there in the middle. My y-intercept is 10 right there. I'm going to connect those two. Alright, I'm going to shade down here, which is going to make everything in here a double shaded region. So let's be super dark in between them. Alright, right there. And then that one continues down here. Alright. Is it possible for a system of two linear equations to have only one solution? Inequalities to have only one solution? Well, that's a wonderful question. It's always a region, isn't it? There's really no way for it to be one solution if it's a system. So I'm going to say no. There is always a region. Why can't a system of inequalities be solved using the same methods of solving a system of equations? Well, because when we do a system of equations, systems of equations only have one solution. I'm going to update that again. Sometimes we have a line of solutions, right, when it's the same line, or a line of solutions. They don't have a region like a system does, right? When writing a system of equations or inequalities from a situation, how do you know that you have possibly written the system correctly? Well, we should have, who knows if it's right, but we should have two equations with at least two variables. So I'll say at least two variables. And we're done. I'm going to post this and I'll see you guys on Monday.